Hello, first of all, thank you for watching my video about AI recognition design. This video summarizes my philosophy regarding my research and design. I hope it proves useful to viewers. Thank you. Recognition begins with assigning names to samples based on human definitions and organizing similar samples under these names to improve understanding. This process is crucial in recognition, where we identify unknown samples by utilizing predefined names and their associated sample groups, selecting the name of the most appropriate sample group for the unknown samples. As intelligence grows, recognition evolves from sample grouping and labeling to establishing more structured recognition paths and scopes. I embarked on research to design AI recognition systems based on this understanding. Recognition principle. Think of intelligence as building blocks. Each block represents a concept formed by assigning a name to a sample. To strengthen initial intelligence, we can link more samples with the same name to the concept. And to deepen it, we can connect different concepts in a structured way, like a hierarchy. Step 1. Recognition path to recognition scope. To specify the enhancement of initial intelligence, I consider a one-to-one mapping of one label to one sample as the fundamental recognition path. This figure illustrates how repetitively mapping similar samples to the same label reinforces a recognition path, expanding the recognition scope from one-to-one to n-to-one as more training samples accumulate over time. Step 2. Recognition path to recognition depth. I establish recognition depth using a hierarchical structure with 3 levels of labels. The figure illustrates how the recognition path transitions from a one-to-one to a one-to-many mapping when employing 3-level labels for the same sample, offering a diverse approach to object recognition. Higher-level labels encompass lower-level labels, resulting in broader recognition scopes and mapping more samples. Thus, the gradual recognition from grandparent to parent and child levels, as depicted in the figure, is vital. Step 3. Outside AI scope and AI with epoch. The figure depicts a scenario where I intentionally picked random samples from a group labeled vehicles to create dataset A1. Now, let's delve into when the recognition scope AI A1, derived from dataset A1, fits within the inside scope, and when it falls outside the scope. Inside AI scope indicates how well AI A1, as shown in this figure, recognizes sample A2 from subset A, not dataset A1, as fitting within AI A1 scope. Depending on the method used to measure similarity, and the applied threshold values, sample A2 might not be deemed similar. Nonetheless, the goal of this study is for AI A1 to accurately classify sample A2 as belonging to the same category. Outside AI scope refers to when the AI encounters samples from a different subset. For instance, in this figure, if AI A1, trained on dataset A1 with vehicle samples, assesses a sample B1 from subset B with food samples, it falls outside the AI A1 scope. Without metacognition, AI A1 cannot recognize sample B1 as outside its scope.